Hi, so this lecture is going to cover the electrocardiogram, and in this lecture we're going to be able to sort of put together what the EKG is telling us, as well as what does that tell us about what's going on with the action potentials in the heart, and what does that tell us about where we are in the cardiac cycle. And so this is really important because a lot of you, when you're nurses, will be having to look at EKGs. And so our focus is not really diagnosing an abnormal EKG, but we want to get really, very familiar with what's happening in the heart on that EKG strip. So the electrocardiogram, I don't know what's up with the K, but the EKG is a way of measuring electrical activity in a heart. And then depending on the kind of machine, etc., we'll place electrodes at different places on a person's body. And again, there's lots of different ways that can happen. And you get a readout that looks something like this. So here's what a typical EKG wave would look like. And on this one, you're looking at kind of two heartbeats. And we would really think about a heartbeat sort of going from the middle of one P wave to the middle of the other. Okay. And we'll talk through sort of why that is in a minute. Okay. When we think about these guys, we think about these waves. Okay. Those waves are showing us change in charge. Flat places are showing us where the charge is not changing. Okay. And the heart sort of has a steady, stable charge. And then we have intervals, which are actually things that are measuring the time it takes for some specific thing to happen in the heart. So you're going to want to make sure that you can very easily name or label all of our segments here of the EKG. Okay, so P wave, QRS complex, this little guy's the T wave. In between the waves, we've got segments, and they're just named for the waves they're in between. And then we have intervals, which usually include all or a wave and a segment, and maybe even parts of two waves. And we'll talk through what all those tell us about the heart as we move through the slides. So, what are these waves in the EKG showing us? So again, our first thing that happens in the heartbeat here is this P wave. Okay. And again, remember the little bumps and divots are changes in charge. And the P wave is showing us the atria depolarizing. If you'll remember, the action potential in a cardiac muscle fiber looks a little bit like that, right? So the atria in this situation are depolarizing. Okay, so there's then we move on to the big, kind of had the QRS complex, which is really big and dramatic. The QRS complex is showing us the ventricles depolarizing. The ventricles are really big, and so you get a lot more change in electrical charge when they depolarize, and that's why QRS is so much bigger than P. And then finally we come out here to T. T is the ventricles repolarizing. So what about the atria? Don't they repolarize? The atria do repolarize, and they repolarize about right here. And it's just such a small little change in charge relative to what the ventricles are doing that it just gets masked and hidden. So our waves are changes in charge. Our segments, we got two of them, PQ and then ST, are flat. So they're flat areas of the line, okay, in between waves. So we've got the PQ segment. So let's think through what this PQ segment might be. So it's a place where we're not seeing much change in charge. So the PQ segment is really kind of showing you that plateau is happening, right? So if our atria depolarize right here, and they're going to repolarize over here, what's happening in between is that plateau phase where there's not a lot of change in charge. And if you'll remember, this is when the heart muscle contracts. So at this PQ segment, this is the time when the atria are in systole. So the atria are actually contracting. They are also, and it means the same thing, to say the atria are in that plateau phase. And then we move on to the ST segment, and that's the same deal except for the ventricles. So with the ventricular action potential, that's in the plateau phase of the action potential. And our ventricles in systole, or they're contracting. So the next thing we think about are these intervals. And again, the intervals are going to have something to do with time. First one is our PR interval. So it's right here at the start of the P wave, basically till the start of the QRS complex. And remember, right in here is where the atria are going to repolarize. We just don't really see it reflected in the EKG. So what's going on during that time? During that time, we have the atria depolarize, contract, and repolarize. What kicks off that depolarization of the atria? Okay. What kicks that off is the SA node. And then the action potential right here spreads through the atria. And then the action potential reaches the AV node. Okay. We still haven't made the ventricles contract though, so we're not here yet. It goes through the AV node, and then it's going to go through the bundle and further through the Purkinje fiber, so through the whole conduction system. Then it'll be time for us to be right here and for our ventricles to depolarize. So what this interval is telling us really is how is the action potential traveling through the heart's conduction system? How long is that taking? Okay, so that's PR. The other one we think about is QT. So from the start of the QRS complex to the end of the T. And what's going on during there? So right at the beginning of QRS, our ventricles are depolarizing. And then they have the plateau, right? And then our ventricles repolarize. So that's the action potential going through the ventricles. So what this tells us is how long does it take for the action potential to get through the ventricles? This one especially varies a lot based on heart rate. So if your heart rate's faster, it'll be a little shorter. So here is a little picture just kind of superimposing the action potential, and this would be the one in the atria. Oh, here it is. And then the action potential of the ventricles on top of the EKG. So as we can see, right here in the middle of the P wave, there goes our depolarization. Here's plateau, so we see this kind of no change in charge. And remember, right in there, our atria are contracting. Our atria depolarized right in here, but that's hidden by QRS. Our ventricular depolarization is detected right up here, and you see right in the very middle of the QRS. Again, plateau, then contraction. Our ventricles are repolarizing, and that is picked up as the T wave. Okay. So again, the EKG is detecting this electrical activity. And here we are showing you the electrical activity that it is detecting. And so something that sometimes confuses people is they say, well, wait, you know, the ventricles here, the charge is decreasing, right? They're going from positive back to resting, but this bump is coming up. Okay, so you don't want to think of the bumps in the EKG as being more positive or more negative. They're just detecting a change in electrical charge. So you just got to learn to relate, okay, I know this T wave is ventricles repolarizing. What does that look like on my action potential? So you want to keep this in mind as we work through, again, should be able to sort of relate this to the EKG wave. Okay, so where are we on the cardiac action potential? We can also figure out what's going on as far as the cardiac cycle. So what is my heart muscle, my heart chambers, what are those actually up to during each part we're seeing on the EKG? Okay, So here we're seeing basically one heartbeat. And so remember, here our atria depolarize. Okay. Here, when they depolarize, they start contracting. They do their contracting during plateau. And they're going to repolarize right here. We don't worry too much about that. Here our ventricles depolarize. And now remember, our ventricles are in systole for kind of two phases, and that's what the different colors are showing you. So when the ventricles first go into systole, remember they're in that isovolumetric contraction phase. And then here's the rest of the contraction here in gold, and that would be the ejection phase. Okay. Then after our ventricles have repolarized, they're ready to relax. And remember, at the very beginning of their diastole, we're again in that isovolumetric phase, but it's an isovolumetric relaxation. And now we go back to sort of the end of this cardiac cycle for this heartbeat, which would be that atrial relaxation, ventricular filling. So something else this shows us is kind of the relative amount of time we spend in each phase. So again, if we clear this off, okay, and we think about the way we've numbered the phases in our book. Okay. Our first phase is atrial contraction. Ventricular filling, got the name in it there, we know is where our atria are contracting. Okay. We divide our ventricular contraction up into two places. So there is our isovolumetric contraction. We know from looking at the EKG, here's plateau, our ventricle's still contracting. Now it's actually doing something. There's our there's our ventricular ejection. So this is where it actually contracts and pushes blood out. After it ejects, we have this little short time period of isovolumetric relaxation. And then from there, we enter into that atrial relaxation, ventricular filling, and we're there, right until the start of the next heartbeat, okay, when those atria depolarize and start to contract. So here again is just two heartbeats kind of broken out in those color things again. So I've just kind of stuck the two EKGs together. But again, we would think about atrial contraction, ventricular filling, isovolumetric contraction, ejection, isovolumetric relaxation, and then atrial relaxation, ventricular filling, and then here we're getting ready to start another heartbeat when our atria depolarize. So let's walk through each of these phases in a little more detail, and that's going to help us also to review the cardiac cycle. So just as a way to get a good review of our cardiac cycle, let's walk through exactly all the things that are happening in the heart during each of these phases, okay? So we know with the start of the heartbeats here at the beginning of the screen. And we know what's happening here is our atria are depolarizing, they're contracting, and then they're repolarizing. That is the atrial contraction, ventricular filling phase, or the very first phase, okay? So remember when we talk about the cardiac cycle for each of our phases, we want to think about the chambers, so the atria and the ventricles. What are they doing? Okay. So the phase tells us our atria are contracting. So we'd say our atria are in systole. Our ventricles can't contract with the atria, they're in diastole. Then let's think about our valves, okay? So our AV valves, if the atria are contracting and the ventricles are filling, they are open. Okay. Our semilunar valves, the ventricles are relaxed, so they're closed. I'm just going to put a C for closed, or CLO for closed. And then the last thing we think about with this is where is blood going? And we have blood going from the atria to the ventricles. So now once we get here to the blue, our ventricles are going to start depolarizing, and that'll start our next phase. So ventricular depolarization, really not ventricular depolarization, but ventricular contraction. Remember, the ventricles are contracting over 2 phases of that cardiac cycle. And when they first start to contract, they're in that isovolumetric contraction phase where they're not really moving any blood. And so that is shown here in our blue phase. And you can see, as we talked about, it's a real short period of time. So our ventricles depolarize, they are starting to contract, right? And so again, this blue phase is isovolumetric contraction. So chambers, our atria are in diastole. Our ventricles, as the name says, are in systole. Valves, this is isovolumetric, also volumetric. All our valves are closed. Blood is not moving. But our ventricles are contracting. As our ventricles contract, okay, and they're able to contract a little bit harder, we're going to move on into this gold phase, okay, or the yellow phase, whatever color you want to call it. So we know our ventricles just started contracting here. By the end of this phase, the ventricles are repolarized. Okay, so we know this is the time period when our ventricles are really in systole. Okay. So here again, they were contracting but hadn't pushed open any valves. Now we move into the ventricular ejection phase. Okay. And in ventricular ejection, then what happens, right? So our atria, again, are in diastole. Our ventricles, we know, are in systole. Valves. Ventricles are contracting, so they've pushed those AV valves closed, and they've pushed our semilunar valves open. Okay. And that allows blood to go from the ventricles to our big arteries. So I'm going to say the arterial trunks, but that would be from the right ventricle to the pulmonary trunk, the left ventricle into the ascending aorta. Okay, so now at the end of our kind of yellow phase, our ventricle has depolarized, which means it's had time to fully contract and relax. Now we're ready for our ventricles to relax. And remember, when they first start relaxing, we have this short little isovolumetric relaxation phase. And just like the isovolumetric contraction phase, it's real short. Okay, and these spaces on this EKG line, how wide these colors are, actually reflects how long these phases are taken. Okay, isovolumetric relaxation. All chambers are relaxed or they're in diastole. All our valves are closed because we haven't built up enough blood in the atria to slam the AV valves closed. But since the ventricles have relaxed, blood's back flowing from the big arteries, pushing those semilunar valves closed. So all our valves are closed. And then no movement of blood. Okay, that's kind of a split second in time. And then, so that's isovolumetric relaxation, short period of time, and then we move on into the purple phase, which is atrial relaxation, ventricular filling. So, chambers, all our chambers are in diastole. Our AV valves are open because our ventricles are filling, so if blood's flowing in there. Semilunars are closed. We have blood from the atria to the ventricles. Okay, while all this is going on, sodium ions are leaking into our SA node. Here we go, our atria depolarize, and we're ready to have another heartbeat. Okay, so put that all together. Your book's got a really nice diagram. Okay, so here's a nice diagram from your book, and it's going to have some more explanation of the stages down below. It's got a lot of graphs that talk about pressure changes, and I don't really want you to worry about those. Those are kind of intuitive if you know what the heart's doing. So don't worry about giving me all these pressures, right? I just want you to know kind of what's happening in the heart. What have we missed? We've missed the heart sounds. So remember, heart sound 1 is our AV valves closing. Where do our AV valves close? So our AV valves will close when the ventricles start contracting, and the ventricles start contracting right here. So there we're going to hear S1, because remember this is our isovolumetric contraction phase. Okay. And then our S2 is our semilunars closing. Semilunar valves close at the end of ventricular systole. So once our ventricles relax, end of ventricular systole happens right here. So kind of right at the end of the T wave, we hear S2. Okay. So it's a lot of information, but it's really important information. So what you need to be able to do is a lot. I'll flip over, we'll make a list. So you want to ask yourself before you're ready to move on, can I completely from scratch draw EKG wave, right? Label all the waves, the 2 segments, and the 2 intervals. If you can do that, you know what it looks like, okay? On top of that, what are those telling us about the electrical activity in the heart? So where are we in that cardiac muscle action potential, right? So we know the P wave is atrial depolarization, right? That PR segment is, or the PQ segment is atrial plateau, atrial contraction. So you want to be able to walk through all of that. And then how does that EKG relate to the cardiac cycle? So if you understand that this particular wave, so say the P wave, is showing you that the atria are depolarizing, you know that right about the middle of that, they start to contract. And then you think about, okay, when the atria are contracting, what's happening in the rest of the heart? And you can kind of walk through that. And don't forget that the cardiac cycle includes those heart sounds. Okay, so where on that EKG, if you were listening to this person's heart and giving them an EKG at the same time, would you expect to hear the heart sounds? All right, so one more lecture, or one more little lecture piece on cardiac output, and we'll be finished with the heart.